All right, this lesson is looking at compound inequalities. This is if you missed the lesson today in class. Today is Monday, the 18th of February, 2019. All right, so if you're going back and you're checking this out, compound inequalities can be challenging because there's a lot of things to think of, but it basically boils down to two words, and we're going to get to see that. Start off with what a compound inequality is. A compound word is one word made by combining two words, like basket plus ball is basketball. In the same way, a compound inequality is made by combining two or more inequalities. It's essentially an inequality with more than one reference point. Now, our inequalities are combined using two different words. The first word that we're going to examine is or. The word or means that at least one solution region. All right, you're looking for at least one solution region. If a point lies in at least one of them, it is a solution to our compound inequality. Let's take a look at question number one to explain what we mean. In question number one, we see here that we want x to be greater than or equal to 5, or we want x to be greater than 0. So let's take a look at a few points here to see what makes it true. Well, let's look at the point 2. Is 2 greater than or equal to negative 5 or greater than 0? Why, yes, it's both. All right, so it's a solution. It lies in our solution region. What about 0? Is 0 greater than or equal to negative 5 or greater than 0? Well, yes, it's greater than or equal to negative 5. It makes the first inequality true. Therefore, it's in our solution region. Even though it did not make x is greater than 0 true, it still made at least one of them true, and I only need one of them to be true for it to be a solution. Let's look at negative 3. Is negative 3 greater than or equal to negative 5? Yes. Or greater than 0? Well, no, but it is greater than or equal to negative 5 and therefore a solution. What about negative 5? Yes, negative 5 is a solution to this because it's greater than or equal to negative 5. It only has to make one of them true. But let's check negative 6. Is negative 6 true? Well, no. Negative 6 is not greater than or equal to negative 5, and it's also not greater than 0. Negative 6, and if you notice, if I come straight up from negative 6 here, I don't hit a solution region. Everywhere else, I hit at least one solution region. All of these points, all the way down here, they're all part of my solution region because they hit at least one of my solution regions. In or, you just need to hit one of them, and we're good. So with that in mind, now that we understand our solution regions and what we're looking for, we can boil this compound inequality down. Instead of saying that x is greater than or equal to negative 5 or x is greater than 0, we could write this in a simpler way. We notice that anything from negative 5, including negative 5, and greater than it made this compound inequality true. All right? Because every single one of those points made at least one of them true. That means that one of these inequalities here is obsolete. I don't even need to say this one here because being greater than or equal to negative 5 covered all of the options in this inequality being greater than 0, as well as the options in our inequality x is greater than or equal to negative 5. So this boils down to just x is greater than or equal to negative 5. For those of you that are confused at the moment, let me give you a realistic example. Let's say that you're going to get your license and you turn 16. Well, what if I told you that in the United States, in order to get your license, you needed to either be older than 21 or older than 16? Well, if you think about that, you'd be like, why would you put the restriction of being older than 21 even on there? Anyone who's older than 21 is already older than 16, so you don't need to say both. Well, that's exactly what we're looking at here. Any number that's greater than 0 is already greater than or equal to negative 5. I don't need to specify that it's greater than 0 as well, all right, because as long as one of these is true, it's true. So that's what we see in number 1 there. Let's take a look at number 2. In number 2, either or, it either needs to be less than negative 2 or greater than or equal to 3. There's no overlap here, and so I can't simplify this down to one statement. But I look at a few points. Negative 5 makes it true. Negative 3 makes it true. Negative 2 does not make it true because it's going through that open circle. 0 does not make it true, doesn't touch any line. 3 makes it true right there. 5 makes it true. These all make it true up here. All right, so we just tested a few points to see our range there. But we can't simplify this because you can't say you can't combine this down to just one statement because it's either less than -2 or it's going to be greater than or equal to 3. A number can't be both of those. All right, and therefore I can't simplify this. We would have to write that answer as two different inequalities. Just state them both. Both are answers here in this case. All right, let's look at the next one. Number 3. Again, I see some overlap, so I know I'm going to be able to simplify this down to one statement instead of using both. So if I want it to be less than or equal to -3 or less than 2, well, let's just look at them all the options. Well, this is a solution, solution, solution. Everywhere I can touch a line is solution. So all of these count all the way down to, but not including 2. It's everything up to, but not including, which means all of these. Well, I just drew one that matched our inequality, x is less than 2. All right? X is less than 2 is all we need in this case because if it's less than or equal to -3, as we see here, then it's already less than 2. So I don't need to say it again. All right, so this one can be boiled down to x is less than 2. Let's look at our last one. All right, number 4, if x is less than or equal to 4 or if less than or equal to 4 or x is greater than -1, then I want to pick numbers that will make either of those true. Well, take a look at this number line. Pick any number you want. Every single one of these numbers all the way across can be followed up and touch a solution region at some point there. They're all right there. Okay? So any one of those would work in this case. All right? So as I look at this, I'm looking at numbers from 4 all the way down and numbers that start at -1 but don't include it but go all the way up. And if you notice, I just covered my entire number line in this case. All right? Every single point on that number line will make this equation, will make this compound inequality true. Every single number is either less than or equal to 4 or greater than -1, at least all real numbers. So therefore, I will say that x equals our special case here, all real numbers. All right? So notice, anytime you had an overlapping region with or, we could simplify it down to one statement, whether that was one of the two inequalities given to us, or if we used here, x is all real numbers. The only time we could not simplify it was in number 2 when there was no overlapping region. All right. So when we look at this, or allows us to have any of the solution regions possible. So you're looking for at least one of those solution regions if you're looking for a point that exists inside of it. All right. Let's take a look at our second compound word here. Let's look at and. And is our second one. And means that both solution regions must apply. We're looking for the overlap here. I'm using the same 4 inequalities, same 4 compound inequalities that we did on the last one. So as I look at the first one here, I want now a number that is greater than or equal to -5 and greater than 0. Well, in this case, is -4 a solution? Well, it's greater than -5, but it is not greater than 0, so no, it's not a solution. Is -2 a solution? No, it's not greater than 0. I need it to be both greater than or equal to -5 and greater than 0. Is 0 a solution? Well, it's greater than -5, but it is not greater than 0. It is equal to 0 in this case. But I do see that anything from 0 and up will be greater than 0 and greater than or equal to -5 because all the numbers greater than 0 are already greater than or equal to -5. So in this case here, a way to look at it is to know that and is looking for the overlap. Look at our two lines. They overlap right here. That region represents my solution region. Everything from 0 on, but not including 0. It's an open circle, so there's no overlap at 0 technically. All right, so this one would boil down to x is greater than 0. That would be the way to simplify that. Let's take a look at number 2. Again, I'm looking for the overlapping region. Are there any overlapping regions in this one? Well, no. We go less than -2 or greater than or equal to 3. They're going in opposite directions and they never overlap. You can't find any real number that is both less than -2 and greater than or equal to 3 at the same time. There is no overlap. There is no point that makes this compound inequality true. Therefore, no solution. We use x equals null. Let's look at number 3. Again, we want to look at the overlapping region. And means we want both. So this is where they overlap. all the way up to and including negative 3. So it's going to be negative 3 and less than. So x is less than or equal to negative 3. And then our last one here, we see the overlap. They overlap in this region right here in the middle. It's everything from, but not including negative 1, all the way up to and including 4. So it's a filled in circle. Now, this is where it's a little bit more of a challenge to write our inequality, all right, because now we can write it as a compound statement. To do so, write your lower boundary and your upper boundary, all right? Then, since the shading is a line in between that connects our two reference points, that means that x will be in between them. And we always use our less than symbols when writing this compound inequality because negative 1 is less than 4. So we have to write this with regards of negative 1 and 4. So we use our less than symbols. And then we decide, can either of those have a line underneath them? Well, x cannot equal 1. It's an open circle there, so no line underneath the left inequality. But on the right inequality symbol, I see that x can equal 4 because of this filled in dot. So I'm going to put the equal sign there for that. I'm going to write this on the left over here. So negative 1 is less than x, which is less than or equal to 4. And that's how I'd write that compound inequality answer. So once again, all ands can always be simplified down to just writing one inequality. If both inequalities are going in the same direction as we see here in the first one, if they're both going in the same direction when we're doing and, we're doing the one that is shorter, the one that's less inclusive, all right? And if we're looking at going the opposite direction, this way here, both go in the same direction, it can be boiled down to just one of them. And again, it's our shorter of them, all right? So and is our shorter one, and we can just pick that out there, that we only need the one that's less inclusive because I need it to both be true. If they're going in opposite directions, as we saw in number 2, there's no solution. And if they overlap going in opposite directions, then there's two reference points. Needs to be written as a compound inequality, as we see here in number 4. When it comes to ors, they can be, as long as there's overlap, it can be written as one statement. If they're both going in the same direction, again, just like and, if they're both going in the same direction, all right, and we have some overlap there, then at that point, we could just simplify it by using one of them. In or, we're using the bigger one because we are more inclusive. When you're using the word or, it includes more people. All right, you could have this, or this, or this, or this, and is a little bit more picky. All right, you need that, and less people will qualify for that. All right, if we're going the same direction here, number 3, same direction for both of these. So I'm using or, so I can just use our one that's more inclusive because it'll have everything we need. Going in opposite directions, as we see in number 2, you just have to write it as two statements. And if you're going in opposite directions with an overlap, seen here in number 4, every single real number will make that true. All right, so let's take a look now at some examples. All right, take a look at this one here. Solve the inequality. 5x plus 21 is greater than or equal to 16. Well, if I have two inequalities, I'm just going to solve them both. All right, sorry, it said or negative 5x minus 10 is less than negative 20. When you have two inequalities in a compound inequality, just solve them both. Do each one separately. So here I'm going to subtract 21. Find that 5x is greater than or equal to negative 5. Divide by 5 on both sides. I did not divide by a negative, so my sign does not change. I find that x is greater than or equal to negative 1. Come to the next one, solve that one. Divide by negative 5 on both sides. And in this case, I am dividing by a negative, which means I flip my sign, giving me x is greater than 2. Let's try and take a look down here. I'm going to put in some numbers here. So we got 0, negative 1, negative 2, negative 3, 1, 2, 3, 4. Now, let's plug them in. My first reference point, it could equal negative 1, and it's greater than, go in that direction. All right, I know that because this symbol is pointing the direction that you should go. Hey, it's pointing that way. Whoop, there's your arrow. All right, in this case here, it is again going that direction, but there's no line, so it's going to be an open circle at 2, and it is greater than, going that direction. So it's one or the other. Or means I'm looking for whichever one has more to it there, because there's overlap. All right, this first one right here, x is greater than or equal to -1, would include all of these solutions as well as the solutions from the other inequality. So this one includes everything that we need. Or you're more inclusive. You need the one that covers more, anything that's in there. All right, let's look at another one. All right, I encourage you to pause the video. Try and solve this one on your own. See what you do. All right, now that you've hopefully paused it and solved it on your own, let's take a look and see the answer. Let's simplify this one here and this one here. I'm just going to solve each. Subtract 10 from each side. I did not divide by a negative, so I get x is greater than -5. Here, add 10. And I'm going to divide by a negative to make that x. And I divided by a negative, so I flip my sign, and I find that x is less than -15. Let's get our number line. All right, that's enough right there. I got my reference points and some equal intervals. So let's put my plot. Let's plot my reference points here. X is greater than -5, so open circle at -5, greater than -5. All right, and I see that x is less than -15, so open circle at -15 and less than. Since this is an or, it could be one or the other. I don't need to look for overlap. In this case, there is none. Since there's no overlap and it's an or, I can't simplify my answer. I just need to write both conditions. X is both less than -15 and greater than -5. All right, and that's how I'd write my final answer. Let's look at the next one. All right, now I'm looking at the keyword and. Once again, solve it. Put your line down the center. I encourage you to pause the video now. Solve it on your own. See if you can get it. All right, now I'm going to go ahead and solve it, assuming you did that. So let's subtract 5 from each side. I find that 4x is greater than -8. I divide by 4. I did not divide by a negative, so x is greater than -2. On this side, subtract 5. Same steps right there. So I get 4x is less than or equal to 20. And divide by 4. I did not divide by a negative, so my sign does not flip. I find that x is less than or equal to 5. So in this case, let's get ourselves some points on here. So I got all right, there's some good points. I've got everything I need. And let's put my reference points up here. X is greater than -2, so open circle at -2, and it's everything greater than. All right, x is less than or equal to 5, so close circle at 5. And everything less than, and I look for overlap. And I look for overlap. Where are both of them true? Well, right here, from -2 all the way up to and including 5. So how do I write my compound inequality as an answer there? Well, it's -2 is less than x, which is less than or equal to 5. Again, you start with your lower boundary and your upper boundary with x in the middle and always less than symbols. And you just have to decide which one is allowed to be equal, in this case 5. And if you're not sure which one's allowed to be equal, again, look, these symbols, look, it matches right there. I have x is less than 5. That's right here, which matches what we have right there. Over here on this side, I have x is greater than -2. I just had to flip it to get it in here so that -2 started. And then it was less than x. All right, so that's just a way to double check your work, make sure things match up. Now, let's take a look at a different way to do this one. Sometimes you'll get a problem and they'll give it to you like this. They give you a compound inequality where they already have 2 symbols in there. Well, when we get to this point, there's 2 ways you can go about this. Number 1, you can see this as 2 separate inequalities, and I can just pull them apart. All right, putting the inside piece with each symbol. And I can rewrite this as 2 separate inequalities where -3 is less than 4x plus 5 and 4x plus 5 is less than or equal to 25. If we do that, that is exactly what we just did. Take a look at our, oops, I'm not using my marker there. Take a look at our inequalities. 4x plus 5 is greater than -3 and 4x plus 5 is less than or equal to 25. Now, this one was just switched, all right, but that's okay. All right, so let's go back. So you could solve it that way, or I'm going to show you the other way to go about it now. Instead of that, I'm going to go ahead and just solve this as a compound inequality all at the same time. If you notice in the last problem, we ended up doing the same steps. We subtracted 5 in both, and we divided by 4 in both. So we're going to focus on what's inside here, 4x plus 5. How am I going to undo that? Well, to get rid of the plus 5, I subtract 5. What I do there, I've got to do on the other side of my line, in this case, both lines. Giving me negative 8 is less than 4x, which is less than or equal to 20. All right. Now, how do I get rid of the 4 times x? Well, to get rid of times 4, I divide by 4. What I do in the middle, I've also got to do on my outsides. I did not divide by a negative, so I do not change my signs. And notice my result is my compound inequality that I was looking for. And it's got my lower boundary. All right, the lower boundary here. And my upper boundary. So I can go ahead and I can graph this on my number line. I can put my lower boundary, so let's get some points down here. Let's go for 0, negative 2, negative 4, 2, 4, 6, 8. There. All right, my lower boundary, well, it could be down to negative 2, but not including it, so open circle. And it could be up to 5 and including it, so closed circle. And x is a line that connects my 2 reference points. It's anything in between. All right, so that's in between right there. And we've got our compound inequality as our answer.